Okay, today we're going to cover section 6.5, which is arc length, and then we're going to talk about surface area of revolution. So let's just think about if this blue curve right here, if I wanted to know the arc length, of course it's going to be a relationship to the distance formula, but right here we could see if we were to take the distance formula that you're used to, x2 minus x1 squared plus y2 minus y1 squared, that's the straight line. Well, we're not talking about a straight line, so we're going to evaluate that with respect to the mean value theorem. So if I substituted our values here, our x sub k, subtract out the x sub k minus 1, that's the x value squared, plus f evaluated at x sub k, which would be your y value at this position, minus the change in y. So basically this is our change in x squared, change in y squared that's related to our graph. Now by mean value theorem, this change in y values can be represented as f prime w sub k, x sub k minus x sub k minus 1. So there's some value w sub k in between here by the mean value theorem. So I'm now taking, this is just a proof, so don't be confused too much by this. Let's just see this through. If I take our values from here and I use the mean value theorem, then this value, this purple portion, in my distance formula can be replaced by the right-hand side of this relationship. So we can see that this is just representing the change in x's, so delta x sub k is the distance between these two. So that's going to be replacing this, and then our change in y values here, we're going to replace it with this, which is the mean value theorem portion of it. Now the rest is just some algebra here, so we can see that if I factored out a delta x sub k, then I would just have this format, because there's a delta x sub k in this term and there's a delta x sub k in this term. So I factor those out and I'll be left with this, and then that's just going to be 1 plus f prime of w sub k squared, and then the square root of a squared term is just the term itself. So I know that's a little bit confusing, but whenever I show you our arc length definition in just a minute, you're going to say, well, how do you get the arc length? And that's just kind of our way of going through that to see why we have 1 plus f prime x squared dx. So that's for us to find the arc length, this blue portion right here, the distance, so to say, or the length of that arc in that position. So take a few minutes, pause it, and write down your definition of arc length. Okay, so our primary focus is to be able to actually evaluate using this formula. In our first example, it says set up an integral that can be used to find the arc length of the graph from A to B. So they tell us a particular portion, so we only care about the arc length from A to B, integrating with respect to x. In this case, our given function is y equals x to the 2/3. I roughly sketched that out. Not that you always have to do so. A lot of these you don't have to do the sketch, but you can if you just prefer to. So I wrote our formula down, and we're going to do some work. Alright, so to be able to evaluate this, first of all we need to know our intervals, and since this is respect to x, we're going to use the x values of our 2 points, and then also you can see that we're going to need what? A first derivative. So let's go off to the side and do the first derivative. On video. Okay, so I write down my y. We're going to come off to the side. We're just doing our scratch work. Our y prime is going to be, the derivative is 2/3 x to the negative 1/3, or that can be written as 2/3 x to the 1/3 power. Okay, so either way, this is also y prime is the same thing as f prime of x. Now let's come put this in. Our first thing is just to set it up. So this would be like the length of, what's our a value? 8, because remember we're integrating with respect to x, so we want to use the x value. So the 8, and then the b is the 27. So it would look like this. 8, 27. We'll set this up, so we'll have 1 plus I'm just going to use that second format, 2/3 x to the 1/3 squared dx. Now, in this particular case, we weren't asked to calculate it. We were just asked to set this up. So this is all we need to do here. Okay, this next thing is just, well, what if it's with respect to y? So we can see that this is just our definition. From C to D, just to denote that it's y values, and then g prom of y squared, that's the only difference. So pause it and write down this definition if it's with respect to, if you're integrating with respect to y. Okay, in our next example, it says refer to the graph in example 1 to set up the integral. So we're going to use that same graph, but this time we're going to do it with respect to y. So look back at that image on the previous one, which is, oops, this right here. Okay, so first we got to change this over to an x equals equation. So we have y is equal to 2/3. If I rewrite it into a radical form right here, and then let's undo the square first. So let's take the square root of both sides. So then that would just give us square root of y is equal to cube root of x. Okay, because this square root undoes the square. Now, our goal is to get an x equals, so if it's a cubed, what can we do to get rid of a cubed root? Cube both sides, so if I cube this side, then I cube this side, then of course this cube undoes this cube root, so we would get x equals, and then this is just y to the 3 halves power, right? Because the index is a 2 of this, and it's raised to the 3rd power, so we'll have this value. Okay, now we need to do the derivative of this. So this is going to be, we'll just say x prom is equal to, let's take the derivative of this side, so that would be what? 3 halves y to the 3 halves minus 1, which is what? To the 1/2 power. Alright, we could change this format, but I'm just going to leave it here for now. So let's come over here. So our L, if we look back, what are the y values? Let me arrow back over to that picture. The y value is, looks like a 4 there and a 9 there. So we are 4, 9. So 1 plus, we have 3 halves y to the 1/2 power squared dy. Okay? And that's all we were asked to do there. Okay, this next example, we're going to see it all the way through. We're going to actually find the arc length from A to B. So we're given our y equals and our A and B. The first thing we're going to do over here to the side, and I'm just going to ask you to look at the green, is we're going to do our work to find the derivative. So x cubed over 12 plus, I moved this x up to the top and just got x to the -1, and then x squared 3x squared divided by 12, right? So n minus 1 over 1. And then I did the derivative of this one, and I simplified. So 3/12 simplifies to 1/4 x squared minus, and I went ahead and brought it down so that it didn't have a negative exponent. Okay, when we come over here, our intervals are in terms of x, so we use the x value 1 and the x value 2. That's what we have placed here. And then we have 1 plus 1 for basically what we have for our derivative. So I put our derivative in, we square it, and we have dx. Now this first problem, I'm taking you through all the way to show you. We're going to work one in a minute from start to finish, but I want you to see the progression of this. Okay, so this part's not too bad. The next thing we're going to do is we're going to actually FOIL this out to the side. So that's what I did in this scratch work. So we have 1/2 x squared, 1/4 x squared times 1/4 x squared is 1/16 x to the 4th. Then I multiplied this term times this term, And the x squares cancel, so you just get a 1/4. When we do this term times this term, we just get 1/4. And then the last terms, we get 1 over x to the 4th. When we simplify in the middle, we get this 1/2. Now this happens a lot, and it's a very common theme with this arc length. So when we put that value right back in here, then we can add like terms. So this 1 minus a half just becomes what? A half, and that's where it's right here. So it's rearranged. So 1 minus a half is just going to be a half. I bring down this x to the 4th, bring down the 1/2 that the blue highlight simplified to, bring down this. Now this factors back, okay? You can see where this part factors 1/2 squared. 1/4 x squared plus 1 over x squared is equal to this value. Well, this is exactly what we have here. So factored form would be back to this. What happens when you square root a square term? You're just left with that term. Okay, so I just brought this to the next page. So at this point, it's as simplified as it's going to get, and we're going to go ahead and evaluate. So we would just take the antiderivative and use the fundamental theorem of calculus to evaluate this. This just becomes x to the 3rd over 12. This becomes x minus x to the negative 1 power. Evaluate that on the interval from 1 to 2. And then you will just see right here where you can calculate that out. Now, I just wanted you to see some of this, especially on this page before we do it, because a lot of this side scratch work goes to happen. Actually, this is a minus here, so it wasn't the exact one, but it's very similar to this. You can go do the scratch work for that. But I wanted you to see here that to factor this, it's the exact opposite of this work over here.